Greetings, everybody, from the TDK Tronics booth. We're here with Julien Romala, the Vibo application engineer. So, Julien, you're the person that people want to talk when they want to put your sensor Vibo in their machine. What is the first thing you need to know about their operation before you can help them?
Well, the first thing is really to understand their need, understand their equipment, what they do, how it's working, and really understand what kind of machine is it, and to be sure to provide the best solution for their needs.
Thank you for that. Now, every machine vibrates differently. When Vibo goes into a motor for the first time, how long does it take to learn what's normal looks like and for the specific machine before it can start telling you something is wrong?
Yeah, it's really process dependent. Some equipments we can do the measurement in a few hours. Sometimes it's a few days. It really depends. Some equipments are really stable for, let's say, months, and they won't change at all. Some equipments are really with different kind of process that are really changing really fast, and then they need a different kind of monitoring in this case. So.
Thank you for that. Now, sensor placement on a machine can make or break the data quality. What is the most common mistake you see engineers make when they decide where to mount a vibration sensor, and what does it cost them?
Well, the main thing is really to use the sensor and to place it as close as possible to the parts that you want to monitor. Typically, the gearbox, the bearings, all of these equipments, you need to be as close to them as possible to make sure that you have a good performance during the measurement.
Walk us through, you're offering a 30-minute sessions with engineers right here on the booth at Hannover Messe 2026. Walk us through what happens in one of those conversations. What does somebody walks away with it from this 30 minutes investment?
Okay, yeah. So first thing, I want to understand what is your need and what is what your need, your equipment, how is it working, how is the best fit for your need, and then if it match, I will show you live our sensor, our demonstration. You will see the direct performance of it, and we can discuss all of these aspects in terms of performance, connectivity, and edge processing capacity.
Got it. Now, before Tronics, you spent nearly a decade testing hardware in automotive and industrial environments. What did that teach you about what makes a sensor actually last in a factory environment?
Well, automotive industry is really demanding in terms of testing. You have a lot of standards that apply to all this kind of sensor. And we apply the same rule for our vibration sensor for industrial applications. So a lot of testing and in different kind of condition, temperature, and all of these aspects are tested to make sure that the sensor will last.
Appreciate for that. Now, we are sitting in front of the demo. What are we looking at? Maybe just point out where is the sensor being mounted and just kind of open up the possibilities there.
Okay. So the sensor is here. So we have one here that is connected to the bus. We have another one here and another one here. They are connected on the bus. So it means you have basically like one cable for all of them. So you have this connectivity that is used. And so the sensor here and here are used to monitor the vibration on the bench. And from there, we see directly the time signal of the acquisition that we made. And we can also display directly the FFT, so we go to the frequency world, and we also have the indicators that are computed directly in the sensor. And then from this, let's say you can, it depends of the use that you want to make of the sensor. So
got it.
So
you have both the hardware and the software sensor that senses and it displays that, right?
For the demonstration, yes, but
yes.
we produce only hardware.
Got it.
Yeah, and but yeah, it shows how to use it, and so you can easily integrate the sensors and use, for example, the indicators to follow trends and say, okay, the acceleration RMS value, for example, is stable. Now we see a deviation. Okay, we need to go more in detail in the analysis, and then we will go to the raw data signal that is available also, and go deeper in the analysis.
Got it. Julien, thank you so much for the demonstration and the insights. And if you have questions for Julien, feel free to follow us. We'll get them addressed by either Julien or someone on Julien's team. Thank you.